I'm back and I'm doing module 17 from unit 4. This is that extra credit little bit of something for ya. And I think it's going to be much the same as module 16. And as I do this, I will use numbers that are a little bit different than the numbers that you will use so that you can do your own work and not my work. You're going to need to do this on Firefox because it needs to use Java, and Chrome doesn't really use Java very well these days. It's going a little slow for me here, so I will pause the video until the thing loads up and I'll come back. Okay, the loading has finished. I'm ready to help you now. Number one, well, before we do number one, let me just show you the chemical equation. There it is. It is the same chemical equation from module 16. Isn't that nice? Number one, we've got solution 3 here. Now you need to find how much AgNO3 there is inside. Here's solution 3. There is AgNO3, but they won't tell you how much is inside. And they won't let you click the aqueous part. You see that? So you need to figure this out yourself. The only thing you can do is see the amount of solids that are in here and gases. Now, this chemical equation doesn't have any gases, but it does have solids. So if I make AgCl, then I will be able to see how many moles of AgCl I made. And if I know the moles of AgCl, then I will be able to know the moles of AgNO3. And if I know the moles of AgNO3, I will be able to know the grams of AgNO3. But how do I know that I have completed the chemical reaction? I mean, I can go here and I can add NaCl. I can add NaCl in order to form AgCl. Here, let me show you. Before I do that, though, let me change the numbers so that my work does not become your work. So I will just add some random amount of AgNO3 there. Okay, so here I have Glenn's solution 3. Okay, Glenn's solution 3 is not the same as your solution 3. Okay, now I'm going to add some NaCl here. Okay, let me add 1 gram. Okay, now look, I have AgCl inside here. AgCl, right? Can I now find how much AgNO3 there was in Glenn's solution 3? Can I calculate that, knowing that the amount of AgCl I have? No. Why? Because I don't know if all of the AgNO3 is gone. I need all of the Ag to be in the form of AgCl before I can calculate how much AgNO3 there was to begin with. Let me show you what I mean by that. Suppose I have my flask here, and there is AgNO3. It is dissolved. Okay? So, you know, when AgNO3 is dissolved, it becomes Ag plus and NO3 minus in here. Okay, so I have AgNO3 in here, and then my job is to figure out how many grams of AgNO3 I had. So if I add NaCl, the NaCl is going to take this and it's going to put it to the bottom in the form of AgCl solid, right? AgCl solid. So my idea is, if I know that this is the chemical equation that's happening, and I know the amount of AgCl, then I can also know the amount of AgNO3. However, look, if I use this amount of AgCl, then I will only be able to calculate this amount of AgNO3. What about the other AgNO3? There's stuff left. I need to get rid of all of the AgNO3. I need it all to be in the form of AgCl. Do you understand? If I have any AgNO3 left here, then when I calculate AgNO3 using AgCl, I will get the wrong answer because there's AgNO3 still left inside the flask that I haven't removed and changed into AgCl. So if you don't understand that, then I will draw another picture for you and explain it to you in a different way. So you're going to have to tell me if you understand or not. I mean, if you don't understand, ask me a question. Tell me I don't understand why I add NaCl to find AgNO3. Yeah, just ask me the question, and then I will help you out with some different picture. Okay? So it is not the case then that I can just calculate AgNO3 using this amount of AgCl. What about this amount? No, because the AgCl just increased. That means there might still be AgNO3 inside there. How about this amount? No, this. You see that the AgCl keeps on going up, you know, but now it's not going up anymore. Look, I keep on adding NaCl, but there's no AgCl addition. What does that mean? That means I have used all of the AgNO3. Look, I'm going to put even 10 grams of NaCl, 10 grams of NaCl, and look, the AgCl is still the same. What does this mean? This means I have used all of the AgNO3. There is no more Ag inside that flask at all. Like, I have used everything. This is gone. This is gone. This is gone. All of that Ag plus is gone into AgCl. There is no more AgNO3. So what does that mean? That means now I can calculate AgNO3 using the AgCl. Okay? And how can I do that? Let's see. What have I got? I've got 8.4033 grams of AgCl, right? Take this up here to the chemical equation. So I have this many grams of that stuff, AgCl. Oops, AgCl. I want to calculate this stuff, AgNO3. Okay? I'm going to do this once. I'm going to use numbers that you are not going to use. And then I expect you to do this for number 1 and for number 2. Number 2 is slightly different. Okay? Oops. All right, here we go. I want AgNO3. I want grams of AgNO3. Do they ask for grams? Yes, they want the mass of AgNO3, so I want grams of AgNO3. So 169.87 grams of AgNO3 are in 1 mole of AgNO3. And 1 mole of AgNO3 makes how many moles of AgCl? I think it's 1 mole, but I'm not sure. So I go look. Look, it's 1 mole. There's no number here, so that means 1 mole of AgCl makes 1 mole of AgNO3. There's no number there, so it means 1, right? Good. Cancel, 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 cancel. And now I know that 1 mole of Ag... Wait. Is this right? Yes. Cl... Ah, yes. Makes how many grams? Let's ask Mrs. Google. $143.32. 143.32 grams of AgCl. And this is how much AgCl I used. So that goes right there on top. Over nothing, over just 1. Okay? and that's going to be grams of AgCl canceling, moles of AgCl canceling. This is the only thing I have left, grams of AgNO3. So I get 9.960. 9.960, oops, there's 5 significant figures. 9.9600 grams of AgNO3. That's what I get. You're going to get a different answer because you're not going to use 8.4033 grams of AgCl. You'll find something else in your virtual lab right there. Number 2. Is there a number 3? That's it, just number 1 and 2. Okay, so number 2. Take solution 4, and this contains an unknown amount of NaCl. You need to find how much NaCl was here, and I will let you figure out how to do that. How are you going to find that amount of what is the amount of NaCl there? How are you going to do that? I'll give you a hint. You could use this chemical equation. Okay? Now, it is not enough to just give me the answer. I need to know what you did, right? It says design and perform an experiment. So you need to write the things that you did. And how would you do that? How would you write those things? Let me show you. You would take your Word document where you're writing your answers, and you would type something like this. I need to make this bigger. Well, here we are. Okay. Oops. Okay. So, wow, this is not okay. I'll just type it small and then make it big later. I added Ag and so for number one, I added AgNO3 solid until the AgCl mass stopped changing. Then I calculated AgNO3 using the mass of AgCl that formed. Okay, that's what I did for number 1. For number 2, what did you do? You added something until what happened? Then you calculated NaCl using the mass of something that formed. Okay, that's how you explain your answer. Explain what you did, or that's how you design. Explain your how you designed your experiment. Here, let me make this bigger for you. Okay, you can you really can just fill in the blanks there. Okay, it's just like that. All right, just like that. Thank you. That was Module 17. And by the way, you've been a great class. I've made lots of annoying errors in the videos and in the class, and really appreciate your patience with those. And I hope that you've learned a lot of real chemistry, and I hope you really had some very interesting times in the lab. I think the lab was the most important portion of the course, and I hope that you'll remember the things that you did in the lab for a very long time, and you will tell your kids about the chemistry lab also.